Okay, acceleration. So we've talked about momentum, we've talked about speed, we've talked about distance and displacement. Acceleration is kind of where we go in the between. So definition of acceleration means the rate of change of velocity per unit of time. So basically acceleration, when you talk about 0 to 60, you're talking about your acceleration point from 0 to 60 miles per hour and how long it takes to get there. That's what the acceleration is. So acceleration is measured in units of meters per second squared. So basically that means that you're moving at a certain amount of meters per second per second. So per second means that you are moving at meters per second, which is how we would calculate our speed, divided by the amount of time it took us to get to that point, that speed. So that's how meters per second works. That's why acceleration is a measure of time more than is a measure of speed. So it is time that it takes to get to a certain speed. That's why it's meters per second squared or meters per second. For example, acceleration due to gravity is 9.8 meters per second. So every second your speed increases 9.8 meters per second. So you keep on increasing speed because of how gravity works on Earth. So after the first second, you're going 9.8 meters per second. After the second second, you're going 19 per 0.6 meters per second. You can see why your speed increases exponentially as you are falling towards Earth. That's what this really means. So in our units, you look at meters per second, kilometers per hour, kilometers per hour, depending on if you are continually accelerating over. But most of the time, we'll do meters per second, or kilometers per hour per second. So what are the three ways we can do that? So there is an increase of speed. So you are speeding from 0 to 60. Now there's a decrease of speed, so like putting on a brake, and a change of direction. Remember, velocity is speed with direction. So not only is velocity speed over time, velocity also has to deal with direction. So when you are putting down meters per second, it can be that you accelerated in a different direction. So I turned right down the street at this many, and it took me this many seconds to do that. So that would be my velocity going down as I turned. Now, calculating acceleration for a constant motion. This is the change in velocity over time taken. This means the final velocity minus our initial velocity. So if your initial velocity is 0, that means it's just whatever velocity that you end up with. Now, if you are accelerating from 60 miles per hour or 60 kilometers per hour to 120 kilometers per hour, you would take the 120 kilometers per hour, subtract 60, and then that would be your change in velocity. That's how we see our acceleration. Now, Natalie accelerates on her skateboard from 0 meters per second to 4 meters per second in 2.5 seconds. So all that means is we take our 4, subtract 0 from it, and then divide by 2.5. So that would make her average of 4 divided by 2.5, because we don't have to worry about what it is. So make sure you put that down. If you would like to use the triangle method, you are more than welcome to. So 4 divided by 2.5 is going to give us an average of 1.6 meters per second. So that is what she is increasing her speed at over that duration of time. 1.6 meters per second squared, or meters per second. All right, next example. Find the average acceleration for a northbound train that slows down from 12 meters per second to 9.6 meters per second. So that means we're taking our final, which is 9.6. We're going to subtract 12. So that means we're slowing down at a rate of 2.4 meters per second, but it took 0.8 seconds to do that. So we have to divide by 0.8. So that means we are moving or slowing down at a negative, so negative meaning that we slow down, 3 meters per second. So when it is negative, when we are slowing down, it is negative. It is possible to have negative acceleration. That's what slowing down means. So Eternal, swimming in a straight line towards the shore, has a speed of 0.5 meters per second. After 4 seconds, its speed is now 0.8 meters per second. So we take our final 0.8, subtract 0.5. So we have a acceleration of 0.3 meters per second. And then we divide that by our 4 seconds to give us our time, or our acceleration, of 0.075 meters per second. So there is some sort of acceleration there, but it is much slower. Think about a sea turtle swimming. It's not like they swim at the speed of a dolphin. They are quite slow, so that makes sense. A car traveling at 22.4 meters per second skids to a stop after 2.55 seconds. So that means we're taking our final, which is 0. We're going to subtract 22.4, which gives us our answer of negative 22.4 meters per second. That's how much we slowed down. But how fast, or how not fast, was our acceleration or our deceleration? That gives us, we take our negative 22.4 and divide 0.2 or 2.55, we get our answer of negative 8.78 meters per second. So slowing down at a significant rate. So how can you tell if an object is speeding up or slowing down? Look back at the examples we have. So when you think about this, if you have an example of a negative acceleration, that means it is going to be slowing down. If it is a positive acceleration, it is speeding up. Now velocity is direction, so if we have a different velocity when things are changing. Think of velocity of a fastball, of a baseball, that's moving at a very fast speed. But if it's a curveball, it has a velocity in a different direction because it is dropping. Now, last example. What would your acceleration be if your speed stayed the same? So you are traveling at 60 meters per second. Then at the end, going 60 meters per second after 8 seconds. All this means is we take our final minus our initial, which gives us an answer of 0. So 0 is going to be 0 divided by 8 is still going to be 0. So there is no acceleration in this case. All right. So if you have acceleration of 0, that does not mean your velocity is 0. It just means that you have no change in velocity. All right. So constant rate. So think about time of graph. So if you look at your graph, you are speeding up or you are accelerating, then you stay constant, and then you are accelerating in a negative way, slowing down. So think of this is how we look at speed versus time. Okay? So show which object is the change of it, which one is it. So how fast is it at 1 second? How fast is it at 4 seconds? Then you go into, this is how we deal with graphs. All right. So we're not going to worry about this today. Slope is just all that stuff. That is